We're going to set the table for a new conversation on food. Really excited to have this person who has been really, I think, leading the charge on food and sustainability and technology, but particularly in the corporate and institutional world. Please join me in welcoming to the stage the Global Director of Responsible Business Compass Group at Google, Helene York. Welcome, Helene.
Where would you like me to sit? There.
So just start by talking about what Compass Group at Google is. Compass Group is a large company that has some other smaller companies, one of which you work for, right?
Right. We're a contract catering company, and what we do is we operate restaurants. So we hire the chefs, we set the procurement policies, and we buy the food and we serve the food. So what I do for Google, which is the client that I'm assigned to, is I advise them on sustainable sourcing policies. I then try to activate it, monitor it, and try to find innovation opportunities in food.
And this is global, right?
4 continents, 23 countries.
Yeah.
I'm on an airplane a lot.
Yeah. Well, yeah. And so you have, I think, through working both in this field and for, sort of the iconic technology company, a pretty good sense of what's happening with technology and sustainability in food systems, sustainable food systems. First of all, I know that it's not all good or all bad in terms of, but I imagine that you come across some of the technologies that are, really great, and there are some that you're saying, well, not so great either. I never needed this. This has no purpose, or it's just not doing what really needs to be done. Give us a little, talk about the universe of technology, what you're seeing in the state of food systems.
Sure. Well, I think we have a very pastoral notion of where our food comes from, or we have a very narrow notion. It comes from the supermarket. And in fact, the supply chains are really long. Most food are grown in rural areas, and then they're shipped to a warehouse, and then they're shipped to another location, and so forth. There's just long chains that from field to table. But I think of this now as from tech to table, because there is no part of the supply chain that doesn't use technology. Some technologies are better than others, some are better developed. Some of the technologies are very proprietary, and I think that's where we have a problem. I understand the need for proprietary technology. I understand the need to beta test things, but there is such a call for traceability and for responsibility in supply chains that technology sometimes narrows who you can go to for information about products. And let me give you an example. There's a great need for technology in cocoa growing. Chocolate, we all love it. It's in danger. Ooh. It is really in danger. Yes, I'm sorry to tell you that, but it really is. There's fungus problems, there's small farm problems, there's lack of infrastructure.
Interesting.
And there's also it's not cool to be a farmer anymore.
In general, around the world?
In general, in so many different places, and in parts of the world where there are other opportunities for the next generation, they're opting out. And that is a big problem in cocoa. So technology, I'll give you an example in the cocoa field, could really help with traceability, understanding through smartphones, understanding where cocoa beans are produced, how much, really sort of helping check up on the labor issues, which are very, very significant in that field, a lot of child labor, some indentured servitude. And then also just really tracing the beans all the way to production.
So help understand how doing that helps both cocoa farmers, but also cocoa consumers in terms of ensuring the supply and the safety and affordability of cocoa beans.
Sure, right now, well, most cocoa is actually produced in co-ops. And so that's a lot of small farmers that combine their beans. And once they're combined, no traceability. And so, and really big black hole in terms of responsibility. So you can have very different environmental management practices on 200 farms. And once those beans are combined, you have a big question mark. And so the technology, if you start with the individual farmers, you're doing a couple things. One, you're bringing technology to rural small farms, which makes it cooler for the next generation, which helps preserve a need, an opportunity to have more cocoa. It also can compare peer to peer. If you have 200 farms, you can see the yields and who is producing what and so many hectares. And if you do that and you see that some are producing a lot less, you understand that there's probably an opportunity for training those farmers on better techniques to preserve their plants, to grow other crops in addition, so you've got more biodiversity. It's healthier for the soil, it's healthier for the products, to manage pests in a responsible way, and it builds up the yields. And right now, we are just beginning to have that technology, but that could be enormous.
I imagine one of the challenges is how do you get the technology to the farmers? I don't know entirely where cocoa is produced, but I know in West Africa is one big area, and you got hundreds of farmers, and what are these smartphones or SMS technologies or scanners or sensors? What is it, and how does it become affordable to someone who lives, pretty hand to mouth?
A couple of things. First of all, to give you a sense of scale, we're talking about millions of farmers, just in West Africa alone. And I think simple smartphones are what's being piloted, and they can certainly provide a two-way conversation among the NGOs partnering with the companies that are buying the cocoa, that are then selling it to the Nestle's and the Mars and others. But it's a good question about cost. The cost of technology has really come down quite a bit. To be perfectly honest, the real stumbling blocks are the governments in a number of these countries.
Why?
They don't necessarily want their people empowered.
Once they have smartphones, and how are you going to keep them down on the farm?
Right, exactly.
Yeah, I think that's an interesting issue, but let's take it to well, it's not just domestic, but I think one of the issues is that there are so many inputs that go into farming, so many different kinds of chemicals, fertilizers, of course, watering, how much, when, and what places, and then there's the part about getting it to market and tracing it, and then even getting the best price and all these kinds of things. But on the input side, how tracking and tracing all of the chemicals, all of the components, GMOs, and other things that people want or need to trace must be a humongous task. And is technology up to that task?
Well, I think if you parse out the hierarchy of questions and say, what are we really trying to trace for? The GMO legislation, for instance, is limited, very limited, and it might surprise people to know that only 6% of U.S. land is actually farmed with GMO seeds.
But almost all corn and soy
and sorghum, and not very many things at all. And our entire 90% of our world's cheese supply actually depends on a GMO rennet. We wouldn't have cheese, but we're not tracing that because nobody wants to not have cheese, so we're kind of forgetting about that. I think technology has a really important role to play in tracing the most important things. And I know the state of California is looking into a lot of avenues. What they have decided is that nitrogen runoff is the most important thing. And when you have really low water tables, you have more nitrates that come up in the soil. And so they've decided from a public health point of view that that's what they want to track. And that is something that can be tracked. I think that there is really an explosion of opportunities that go after one thing. And what we have to look at, and I think the question is, why do we want that information? And if there's a material public health reason, that's an important reason. But if we are trying to use a technology, let's say, that traces, that you have to use essentially a litmus test to find out if each piece of fish that comes into your restaurant is a certain level of mercury, that's really not very feasible. And it also suggests that you're only testing for one thing on a piece of fish on a plate. You know, there are omega-3s. There's all kinds of other heavy metals.
Testing to make sure the fish is actually the fish you think you're buying.
Yeah, I mean, there's just a lot more that I think is important.
So Google has a food innovation lab. Are they working on some of these? I know you're not employed by Google, but you must see some of what's happening. What's going on there?
Well, a lot of it actually is, I've signed an NDA to unfortunately not talk about some of them, but I would say that they're very big picture ideas and that, you know, feeding the world as opposed to preserving, you know, specialness for, you know, one aspect of high or very expensive food. So they're really looking into you know, what's going to affect 1 billion people. So we've talked about chocolate. That's one of them. I know some other areas that I've looked into with some Google support, so not specifically the lab, are things related to aquaculture, responsible aquaculture. Aquaculture has a really bad name and deserving from the early years, but right now has really moved tremendously through new technologies, offshore technologies, very, very sustainable transportation methods where you boat fresh fish rather than air freight it. So it's 1/10 the carbon cost of getting from point A to B.
We hear a lot about some new ways of growing food. There's aquaculture is one of them. Indoor farming at scale, urban agriculture. You mentioned to me earlier the underwater farm, I think in Milford, Connecticut. That you're kind of excited about. Talk a little bit about that.
Yeah, it's called 3D ocean farming. And you go out on a little boat and you can't see it, but it's seaweed and mariculture. And I tasted the product of that farm, which was a kelp fettuccine. It was really good. I mean, it didn't taste like weed. It looked like spinach fettuccine, and then thrown in with some of the mussels and clams that were actually harvested from the same place. I mean, 3D ocean farming is not only underwater, but it's multi-species. So it's good biodiversity. It's called multi-trophic aquaculture, fancy term, underwater, but it really allows for the filtering and the life of the farm, just like biodiversity in the soil. It's the same thing.
Elaine, let's get a quick question in.
Yeah, so we are getting a few questions specifically around big ag. One was, you know, is urban farming a pragmatic adjunct to the agribusiness system, local production versus different eco-environments? And also, how will technology enable the disruption of big ag in the US? So really, what do you see in terms of technology's role and also, you know, more localized production versus centralized and all that?
Well, I think localized is a funny term. In different parts of the world, local means different things. And, you know, in the Bay Area, we have a tendency to think hyper-local, but that's because we're affluent. In North Korea, very different situation. I don't have any experience directly in North Korea. I'm just about biggest differences. I really see the future of agriculture in the ag of the middle sector, not in really big ag, not in really small ag, not in hyper-local and not in global, but really about where do we find the best locations to grow some of the best food. I mean, in Vietnam, for instance, probably the best place to grow responsible fin fish, as opposed to, you know, shellfish. Very high in nutrients, very high in protein, can be grown very, very responsibly and can be transported in a very efficient way. The ag of the middle farmers, and I'm talking about those with 1,000 acres or 500 hectares, not the 20 acres and not the 10,000 or 100,000 acres. These guys are hungry for new technologies. They're using them. They're using heat maps, GPS enabled tools on their tablets as they are on tractors, as they're walking on feet. They are recording the history of their spaces so that they really can reduce the number of chemicals that they use, and some of them have reduced it by 90%, and just have a much more biodiversity on the land so that they don't need the chemicals.
We're kind of out of time. We're going to get played off the stage by the band in a second, but I just have to, we talk a lot about food and the 60 to 70% increase we're going to need by mid-century to feed the 3 billion more mouths that are going to be hungry. And it kind of often feels doom and gloom. Just in sort of 25 words or less, are you optimistic or not optimistic about the ability to meet those goals and particularly the role of technology in that?
I am optimistic in the role of technology, working with private industry as well as governments. NGOs also have a role here too. I think we also have to think about behavioral science and how we ask the question, what are we trying to accomplish, and how can the technology tool be a part of the solution?
All right, so everybody needs to be at the table. Please join me in thanking Helene York.
Thank you. Thank you.